Okay guys, here we want to learn about something new, and it is a geometrical app called GeoGebra. Okay, you can download it for Android, iOS, and also you can use the website. Just for starting, I want to just show you that even if you check the logo of the GeoGebra, you can see here on my screen switch calculator. Okay, beside this you see a curve. It is a conic section, and you see basically 5 points here. Why 5 points we want to see now? It is a conic section and 5 points you see. It is determined with 5 points. We want to now check that whether we can determine a conic section with only 5 points. Indeed we can, and I can tell you that given any set of 5 points on your screen, on your 2D screen, not 3D, only 5 points. There exists a unique conic section which can pass through these 5 points. Let me show you. I will, for example, here arbitrarily choose 5 points, and I can check that whether a conic section passed through this. Okay, I will check here circles and circle with center, etc. Polygons, transform, media. Somewhere should be a conic section here. Okay, previous versions include, and also this is it is the logo of the software, so it should include also this feature. Let me find it, so you have a chance to see that how we can do this more maybe. Okay, you see connect through 5 points. It is actually okay. I just click on this and I start selecting the points A, B, C, D, and E. Okay, we see that now an ellipse passes through these 5 points that I have selected on my 2D screen. According to the appearance of your points, you can have an ellipse or maybe a circle that should be really specific to hold on to satisfy on a circle. But we know that from, let's say, geometry in our high school. We know that there is only it suffices that we have 3 independent points so we can pass a circle through it. But it is let's say it is the conic section can be determined by only having 5 points of it, and we want to see why. Okay, here on these specific points that I have selected, A, B, C, D, E, we see that there is an ellipse which passes through these 5 points. But for other configurations, you can have ellipse. So here we see the ellipse, hyperbolic or parabola, and also specific versions of this. Let's say, for example, you have 2 lines with conjunction with each other. So this is actually a specific case of hyperbola. Okay, and we want to see whether it gives us the equation. We can have let me check, switch to a calculator. No. I want to see whether I can check because when you also install the GeoGebra, for example, on Windows, you will immediately see the equation. Anyway, let me check the settings here because, okay, coordinates and algebra. I want to see the equation. Here I believe that, okay, by just clicking on algebra, we can see the equation. For example, here, connect through A, B, C, D, E, and I want to see that. What is the equation? Point E, point D, yeah, point E. You can see now the coordinates of independent points C, B, A. Also, you can on the grids, but I believe that it is better to have them off. We can switch grid on or grid off. And here I want to see that whether it shows the, let's say, algebraic equation of this conic section, because it is important. Maybe for this option we need to, so points, by clicking on them I can see the coordinates. Okay, if it shows the, let's say, the conic section itself, let me check. Equation. I want to see that whether it is possible to, let me click on this, see that whether we can see the equation or no. Okay. Maybe it is just CAS, computer aided algebra. Maybe I should start for being able to see the equation. I need, maybe I have to start from something else. I need to check the grids, but previously I have just shut down the grid. Okay, show grid. Okay, show grid, and maybe show equation. Maybe we have something. I want to check that more, again, more here. On Windows it is easy actually, but here I want to see that. Okay, grid type, point capturing distance on a label, show access also, and algebra, graphics, show access grid type, point capturing, automatic distance. Okay, general coordinates I can see in this way, so okay, if I click Okay, so here we are. If you again, after switching on the grids, you can see that we can see each point. Now I added the points, the 6 point myself, okay? But technically you only need 5 points. You can add additional points, but at least you need 5, and we need to see why. Here we have the equation of this conic section, okay? We see that 1, 2, 3, 4. We can see the coefficient of x to the power of 2, okay? And we can see the coefficient of xy, coefficient of y squared, coefficient of x, coefficient of y, and also there is a constant here equals with a number minus 338.6. Okay, if we check here the equation and divide both sides, I mean that both sides of the equality to this coefficient minus 11.8, you will get here 1 and some other numbers, okay? You will get here the coefficient of the x squared will become 1, but the other ones will become some number. Here, number 1, let's say. It is something, okay? Minus 5.1 divided by minus 11.8. That's some number. We call it number 1, the coefficient of xy. The coefficient of y squared, number 2. The coefficient of x, number 3. The coefficient of y, number 4. And this final value, actually final value is minus 338.6 divided by the first coefficient minus 11.8, okay? And this is number 5. You see 5 numbers. If for each conic section, according to the equation, I have 5 numbers. Just let's say, do not consider the coefficient of x squared because we have already divided by it. So I have 5 independent numbers, and you see that if you have 5 points, you can independently determine this coefficient, okay? You have, for example, let's say in this way, you have as the equation of a conic section, you have x squared plus axy plus by squared plus cx plus dy equals with e, okay? Or plus e equal with 0. You have 5 numbers. If you have 5 points, you have 5 different x and y's. You can just put them in this equation and find a, b, c, d, and e. They are just 5 coefficients uniquely, and they can be uniquely determined by satisfying the point. The points are 5 points, the coordinate of our 5 points in this equation, and you can find, you can now understand that why you need 5 independent points to have on the 2D screen, and that guarantees you that you can have a conic section passing through that. Here you see if I begin to switch 1 point, I will have I can see that the equation changes also. We can see that the coefficients also changing, and the type, let me zoom out, and we see that if I can, sorry, no, not point. Here I'm shifting this. I need to okay. Okay, you see here now I have a hyperbola. You see one coefficient of x squared. Now it is positive. Coefficient of y squared. Now it is negative. This is a finger point. Let's say a unique characteristic of a hyperbola. I have some a multiplied by x squared minus by squared. A and b are both positive. Forget about the cross terms xy. We can rotate the curve. In analytic geometry, we have the tools for rotating our xy screen to actually come up with a new coordinate which doesn't have xy. So they, for example, this equation will become something like this: ax squared minus by squared equals with something. Okay, equals with something. That's something, let's call it c. Ax squared minus by squared equals with c. And actually here we have a multiplied by x minus alpha squared minus b multiplied by y minus beta squared. It is equal with c. You see, again, we need to have 5 values, a, b, c, and alpha, beta, to determine this hyperbola. By varying the points and the curve shifting, and you can see that you can have different type of equations. Let me just see that whether I can do it correctly or not. You see these 2 lines, now another hyperbola, another thing. So this is now an ellipse. We can see different type of conic sections. Basically, there are 3: ellipses, parabolas, and hyperbolas, and specific versions of them. For example, in the case of hyperbola, I can have you can see they are looking just to conjuncting lines. So yeah, this is I believe that it is a correct introduction to GeoGebra. You see that this software has this wonderful logo, but I cannot show it here. Yeah, you see a conic section with 5 points, and you can see and remember till the end of your life that why for determining a conic section uniquely you just need 5 points. And thank you so much for watching.